1 over x. What's the... Yeah, because the denominator, if the denominator gets super, super big, we have 1 divided by that. That's going to make that number get smaller and smaller and smaller. Okay, now let's think about the graph. The graph looks like this. So doesn't that confirm that? If I would go closer, it's a horizontal asymptote, right? Okay. And then, now, tables for this are a little bit different because we're doing x approaching infinity. So if I was going to do a table for this, I would do like 10, 100, 1,000, and 10,000 maybe. You could do more if you needed to, 100,000. So let's just confirm it. We call that confirming it numerically because we're putting in number values. Okay. What does 1e negative 5 mean? 0.0000. 1, 2, 3, 4, 5. Point. Oh, it was a 1. It was a 1. Point 0001. 0.001. Okay. Is this confirming what we thought? Yeah. So the limit as x goes to infinity of 1 over x is going to be 0. What would happen as x approached negative infinity, by the way? Same thing? Okay. It's approaching from the negative direction instead, but still approaching 0. All right, cool. Let's try this one. All right, so I want you to think about this one. What do you think about that limit? This is kind of thinking about, we're going to only do these with not our calculators next unit, or next chapter, not next chapter, next section. So I want you to at least start thinking about it. What would happen if you put a really, really large negative number in here? Awesome, I'm glad you noticed that. Why would it be positive? Because it's squared. What else would happen? It would drive this thing to 0, correct? But then there's this after it. So what do you think the limit, what's your guess? What's the limit of this?
2.
Joey says 2, okay? Let's check it out graphically. What did I do? I think I just had my window. All right, now over. I just did Zoom 6, the standard window. So I'm gonna just, for the heck of it, put in a line at 2 just to confirm that that's like it's. See that it is approaching that line. Okay, and you would notice the same thing in a table of values. I left my table in there. That's sweet. Just look at the table. Hey. Isn't it approaching 2? Ignore that one because that is 2. It gets so close, in fact, that it's saying it's 2. It's rounding it to 2. It's not really. All right, so this limit would be 2. Last one. I like this one. The limit as x goes to negative infinity. We're going to do 2 of them, of e to the x sine 3 pi x. You should remember this, maybe. once you see it. And we're going to do this one too. I'll give you a hint. This is referring to damped oscillation from chapter 4. Do we have a trig function? Trig functions are going to oscillate, correct? But what's in front of the trig function? E to the x. E to the x is an exponential function that looks like, correct? So as x goes to negative infinity, he thinks it's going to continue to get smaller and smaller and smaller. Let's take a look. We're looking at the first one now. Sine. No, you were right, because as x goes to negative infinity, you have to think about this isn't going to matter, because it's going to continue to oscillate back and forth. So this kind of bounds our function. It's like the boundary of our function. What does this do? You should in your head know if something's exponential growth, if x is approaching negative infinity, that's going to approach 0. So the limit of this one would be 0. We could look at a table of values to confirm this. If I would go into my table and instead I'm going to change these all to negatives. By the way, anybody know why this is an error? This one's so big it can't calculate it, actually. But if I was doing negative infinity, hey, look at, what's it saying? Yeah. Why is it saying 0? Is it really 0? No, it's so tiny it's rounding it to 0, and so that would be its limit. Okay? Okay, you guys tell me then, what's the limit as x goes to infinity? Yeah, technically it doesn't exist, but we would say it so I'm going to write does not exist, but approaches infinity.